Well, good morning, Peter. Well, it's now Wednesday, next day, and we're continuing with the discussion. And Peter, I think yesterday we stopped off, it was around 1992 or 1993. Eugene had spent a year at École Polytechnique with Art Pelton and Chris Bale, and then he came back to Queensland. So maybe we'll pick it up there.
Yeah, so Eugene has done his postdoctoral work at CRCT in Montreal, and that was funded principally by coal companies at that time who were looking to see how they could predict the properties of ash resulting from coal combustion. So that basic system, the alumina, silica, iron, lime system, is really the basis of a lot of metallurgical slags. And so there was a clear synergy between the coal ash systems and what we wanted to progress in terms of developing the phase equilibria and developing techniques for characterizing these complex slag systems. So there was a synergy there. Eugene started work on the FactSage databases. He'd already, during his time in Montreal, prepared the lead slag database with Art and Sergey, and he went on to do the base system for the coal ashes and then build viscosity models based on the thermodynamic models. So that's the basis of extending the thermodynamic database into physicochemical property modeling. That also started at that time. So that was an important growth period for us, and strong relations with Montreal helped us develop that. At the same time, the experimental techniques that we started to progress with Eugene started to produce some really good results. So we'd extended our range of systems from originally the lead smelting slag systems for the Isa smelt at Mount Isa. We went on to do zinc blast furnace slags, which are nobody had previously characterized because of the difficulty in handling those high zinc slags, and extending it into other systems. So there was a period of progression into a whole range of different systems. Cerro Matoso, nickel smelting slags, and it just grew, the list grew, and it turned out to be a very successful development. And as we went along, the techniques, we expanded the range of chemistries and started to push into areas where which people hadn't been able to measure previously. And I think industry then started to take notice of that and say, well, we're getting close to the slags that we're using in our plants, rather than idealized binary or ternary systems, which are a long way away from metallurgical practice. And so I think we gained traction with the industry, and then industry support started to come to keep the momentum going in the development. So so things were going quite well into the early 2000s, and that also led to the establishment of the Pyrometallurgy Research Centre, which we call PYROSEARCH.
So tell us a bit about that, Peter, how that began.
Yeah, the then head of department of mining and metallurgical engineering, Don McKee, clearly he's supportive of the fact that we were being successful there, and we also had an entrepreneurial vice chancellor at that time, Paul Greenfield, and he was previously head of chemical engineering, so I knew him quite well, and the climate was right, I think, to progress to the next level, not just being an academic working with a research group, but to actually expand the activities. And so the university had embarked on this policy of establishing centres within different departments and within the university to enhance the profile of that research profile of those activities. And so the opportunity came up to establish a centre. So Eugene and I worked together, I guess co-founders of what was then called the Pyrometallurgy Research Centre. But we gave it the acronym PYROSEARCH to try and give it a commercial edge to it. And we've used that ever since. I think that's been quite successful. As in 2018, that is still going. We've changed the name slightly to Pyrometallurgy Innovation Centre recently for a number of reasons, but that's going well. And I was the founding director of the centre, and Eugene was the research director, and subsequently Eugene has become the director and I've stepped aside. So he's driving that process.
So tell us a bit about that. You did lead slags, zinc blast furnace slags, in between, I think, copper slags, ferrite slags, and so on. Tell us a bit more about the nickel laterite slags. Cerro Matoso was interested in some work on their complex slag.
Yes, Cerro Matoso is a nickel laterite process, and that particular operation, BHP's operation, Cerro Matoso, the slags were in the silica primary face field, which is a bit different from most of the other deposits in laterite deposits in South America and other places. And there really wasn't much information about that. There was only one previous study on that system. I think it was Bowen and Shearer. That's, you've caught me there a bit on the reference.
I think it was a Billiton study.
Yeah, BHP Billiton at that time.
Yeah.
And they were in the silica primary face field. There were issues about understanding the liquidus temperatures of those slags and how the impurities might affect that. And the technique that we've developed enabled us to measure those liquidus temperatures. So this was important for furnace integrity because of the establishing the cooling characteristics in the furnace and the superheat between the alloy and the slag, knowing that information. And we were able to show the effect of alumina, for example, 1 or 2% alumina in the material had a dramatic effect on the liquidus. 50 degrees drop in liquidus temperature for every 1% alumina. And I think we did a pretty good job in characterizing that system and extended that further over to the olivine and pyroxene fields. So I think that was personally I was quite satisfied with that study, and I think it turned out to be quite useful.
Yeah, okay. So Peter, we've just talked about the various slags and metal systems, lead, zinc, copper, nickel, significant work in nickel. And that work continued with some other systems. Maybe we might sort of discuss some of what you think the technical contributions to the industry, and perhaps any recognition that this work has, identified within the community.
Yeah, thank you. So I think my contributions have been in a couple of areas. One, my ongoing interest in reaction kinetics and mechanisms, something I started way back when I was doing my British Steel Corporation fellowship. And I still have interest in those gas-solid reactions, still doing research on that and characterizing that. So I feel I have made a contribution in that area. I'll come back to that in a second. And the other area is really the development of these experimental techniques to provide us with this additional information on the phase equilibria. I'm not personally a modeler, thermodynamic modeling. That's not my expertise. But what I can bring my knowledge of microstructure and relationship to phase equilibrium and thermodynamics, and bring that connection and show, help to identify what the important things that we should be measuring. And I think that's led to the development of this, the techniques, and now the modeling, development of the modeling. I think that's laid a platform for us going forward to develop these tools, which are now being incorporated in computer packages. So at the time we set out the computing capability that we had in the world, it's a bit hard to comprehend now, but when we started out, the models were very simple, and computing power was very limited. So now, 20 years on, everybody uses computers. The speed and capacity of the computing systems are so much greater, and that means the potential for use of these databases for predictive tools, instead of being something that's just an academic interest, has now become a mainstream tool that the industry uses every day. And I think it's been satisfying to see that transfer of fundamental knowledge into practical tools that the industry can use. I remember talking to members of the coal industry back in the early 90s and saying we could develop this tool, and there was quite a bit of resistance about why do we need this stuff, and we're never going to use this these esoteric approaches in our industry. And now the reverse is true, that everybody goes to the thermodynamic models and data that's available as a routine part of the planning and development of their technologies. So it's a complete reversal, and so to be part of that, I think, has been quite encouraging. And some of our work has been acknowledged. That I'm happy and quite proud to have received some awards from TMS, a Science Award for Extraction and Processing Division, for some of the papers we produced in Metallurgical and Materials Transactions B. So that's I'm quite proud of that. We've had 3 awards from TMS and also from CIM and Institute of Metals and Materials in London as well. So it's good to have some acknowledgements for peers, and I've been lucky enough to get some acknowledgement this year in the symposium here in Ottawa. in my name. So it's I'm quite feel quite humbled by those acknowledgements.
Yeah, I agree. The symposium has been a remarkable event, and it's still going on. So, Peter, you're working in Brisbane. Support from Mount Isa. I think you mentioned Xstrata. We could perhaps cover that a little bit. Mount Isa was several hours flight away from Brisbane. You did a lot of work there. I think work with Kalgoorlie and so on. So, what about changes in the Australian industry? How you saw that influencing the work of the centre, and then you were reaching out to Canada. You worked in Colombia, and possibly perhaps some of the Japanese industries. So how did that all mesh together, and how did you see all those changes?
Yeah, that was part of a management on my part. I guess I had to find sponsors, I guess, for our research. At that time, there was in the 90s, there was still active research going on at the University of Melbourne. There was the G.K. Williams Research Centre, and
Port Pirie, I guess, had a group.
Port Pirie was going, but a lot of that, the establishment of the research centre in Melbourne attracted support from most of the Australian smelting community. We weren't part of that centre, and because of the limited funding available from industry at that time, there wasn't a lot of scope for us to do research and to have our research funded. So basically, to survive and to expand, I had to actually go and seek industry outside Australia. And so I travelled to South Africa and Europe, basically around the world, to get research sponsors. And so that the fact that we weren't able to, and we also had difficulty getting government sponsorship at that time. So the fact that we actually had difficulty in getting funds internally meant that I literally had to go overseas, and helped us to internationalize our operations, which in the long run, that was a good thing to do, rather than looking internally and relying on local support. So we started with very strong support from Mount Isa mines through the lead and zinc, and then that continued with Xstrata, but we broadened our base, if you like, internationally. So that's really how we extended our operations, and I think that helped us in the long term, as I say, to broaden the range of systems that we studied.
So Peter, how do you're now global, and what sort of changes in the industry have you seen, and how does that affect the work of the centre, and where do you see some of these changes going? How will the centre react to the various changes, mergers, acquisitions, the rise of China, and so on and so forth?
Yeah, so there's been quite a big change in Australia. The number of smelting operations has decreased, relatively small number, and they've increased other places in the world. So Australia has become more an exporter of concentrates rather than the processor of those minerals into refined metals, which personally was a bit disappointing. I would like to see in Australia do more with the mineral wealth that it has. but that's not my decision. But on the other hand, we are able to support other operations, and it's heartening to see the resurgence of process metallurgy in Europe because of the realization of the need for recycling of metals. And so as time has gone on, we've actually moved more into those areas and support for recycling. So we have strong support from European metallurgical companies now, and helping those companies to handle the diversity of the elements, in more complex systems, chemical systems, more elements and different combinations of elements coming into our metallurgical operations. And then for the need for these predictive tools is becoming more and more important, because we can no longer deal with systems which are relatively simple coming from the ore, but we're adding into the mix all sorts of combinations of primary and secondary materials coming in. So there's a broad spectrum of elements which need to be recovered, and the predictive tools are, as I say, are becoming more and more important. And I think in the future, not only help us in process development, but ultimately we'd like to see those tools incorporated in the operations, in determining the optimum conditions in the processes, and in the optimization of those complex flow sheets. So where the partitioning of the different elements between process streams, to be able to predict that and to design and to operate the different unit operations to optimum efficiency. So I see the application of the basic data now flowing back into the industry, and as my colleague Eugene Jack was saying in the symposium today, that he'd like to see a predictive tool, a virtual reactor type of models, so that industry can predict what's going to happen, so we can use basically feed-forward control in our process systems rather than reacting to things which had happened half an hour or 2 hours ago, and which we've got no chance at all in controlling. So,
no, I think this is fascinating, Peter, and I guess that's where you see the work of the Centre moving. I think somebody said yesterday in one of the presentations, something like 80% of the gold that has been mined is still in circulation. And I suppose there's a similar figure for copper. So that all connects with what you're saying about the circular economy that's commonly used today. Peter, we very interesting discussion about how the Centre was internationalized, working globally. But meanwhile, back at the university, another primary role is education, and education of undergraduates and, I guess, postgraduates. So maybe we can go a little bit back in a parallel kind of activity, how you saw changes in the education and how you made improvements and how it's seen. And maybe we'll cover it toward the end of this little segment. How can we attract more students into mining and metallurgy?
Yes, so in the late 90s and early 2000s, the focus was on establishing a strong research presence, and so I put a lot of effort into that. At the same, in 2004, the university, and particularly the faculty, was faced with a financial difficulty, and there was essentially a 10% cut in budget had to be made. And metallurgical engineering was one of the smallest programs in the faculty, and so we were in the firing line to whether we would continue to exist. In fact, we lost one of our senior professors because there was a 10% cut of staff in all schools. So that threatened the life of the metallurgy program, and to be honest, we were within 2 weeks of being shut down by the university, and the executive dean or the dean of the faculty, he was very sympathetic to what we were doing, but he had a job. He had to balance the budget. I mean, that was his job. But I managed to persuade the dean to talk to some people in industry and say, look, this is a very important program for the industry. If you shut this down, this is going to have a major impact. And there was a person one of our former graduates, Joe Peace, who was with Xstrata, previously Mount Isa Mines. And I contacted Joe and said, look, Joe, we really need to get someone talking to the university about the potential impact of this change. And Joe then made contact with the industry and the AIME, and we managed to persuade the then dean to set up a working party between the university and industry to look at the future of metallurgical education at the University of Queensland, and also mining, because mining was also, there were some questions about the mining program at that time. So they set up a joint working party. I was asked to be on that working party, representing the metallurgical industry and the education potential, I guess, from the university side. And the industry came to the fore. The panel was chaired by the president of the AIME, and out of that working party, they analysed what it was necessary to keep the program going. At that point in time, I proposed a dual major in chemical metallurgical engineering as the way forward to provide the skill set for the industry and to provide pathways to attract people into the program. That was a bit of a radical departure from the then types of structures that conventionally offered in metallurgical engineering. But that was taking into account, I guess, what the industry needs were in terms of skills and attributes, but putting together a program that we could actually deliver. But the other point was that there's no way in the world, with the numbers of students or graduates that the industry wanted in Australia, there was no way that that was going to be economic from the university's perspective. In fact, the maximum we could possibly achieve was maybe 50% of the cost of putting on these programs. So the minimum class size would have to be 50 students for every year. And at that time, there was no program in the world that produced 50 students in metallurgical engineering a year. It's an impossible target. And so the industry came to realize that. And so there was an agreement that if our target was about 25, that represented half the cost. So the industry would contribute in various ways to make the other half. And so a partnership between the university and the industry was established. And that led to support from Minerals Council of Australia, essentially supporting equivalent to one academic position. Then Xstrata also contributed a position, the chair in metallurgical engineering, and BHP through BMA also supported a position. So we had 3 academic positions which were essentially supported by industry funds, and the other 3 were contributed by the university. And so both sides were happy that the university was happy that they were getting some support to keep the program going, and that gave us the potential to hire staff, because at that stage I was the only person left in metallurgical engineering.
Plus Eugene.
Eugene was part of the research centre.
Okay.
He was not funded by the university.
Okay.
That was all funded by external funds.
Right. Okay.
I was the only one left standing.
Right.
Right. And so it was one of those periods in time where, as you say, it could have gone quite easily. So the fact that we had support from industry meant we could go out and hire people again, and that's what we set about doing. And now the dual major in chemical metallurgical engineering is still going now. It's been quite successful in attracting students into the program. It's a flexible entry into the program, and but we haven't thrown out the specialist metallurgical engineering component. So we've combined the core metallurgical engineering with process engineering from chemical engineering, and we have a good working partnership with that branch of the discipline now.
And so, Peter, that is continuing, and perhaps we could talk a little bit about that. And then, how do you see continuing to attract students in terms of the fact that mining is often seen as an environmental problem? I like the comments that were made yesterday at some of the presentations that in terms of climate change, recycling, circular economy, that I think the comment was mining is part of the solution rather than causing the problems. So do you want to comment on some of those aspects in attracting students and so on?
Yeah. I think if we go back 30 years ago, 40 years ago, that mining and metallurgical engineering were seen as specializations. With this dual major program, we've tried to broaden that context so that the students have more flexibility in their career paths. So because they come out with a degree in chemical engineering as well as metallurgical engineering. So flexibility in career paths was the important factor at that time when we set up the program. At that also, the industry was conscious of the environmental impact of mining in Australia maybe 20 years ago. And I think that was an important environment to recruit students. Unfortunately, I think we've had a regression over that period of time in the attitude of some of the major companies who've walked away from the environment. So there's been opposition to and denial of the impact of CO2, for example, on the environment. And we've also seen a decline in support from the major industries. So I think if we're going to attract people back into the industry, we have to have a climate change from the industry to get back to the message that they were promoting 20 years ago. That is, they're also taking care of what they do with their resource. They're going to rehabilitate that land and the mine. They're going to take care what they do with their waste. So in Europe, it's very encouraging that that's taking place. I think we had to spread that message to other parts of the world if we're going to attract students back in to the discipline and give them this challenge about being what I call the guardian of the elements, because that's what I think metallurgists are. 85% of the elements in the periodic table are metals, and as metallurgists, we should be looking after that resource. But the other thing I think the industry needs to do more to attract students is to get them involved. There's been a disconnect between the industry and their recruitment. So the industry has assumed that there is a ready supply of graduates coming through, and essentially, since the financial crises, the emphasis has been on cost cutting, and I think we have to give our young engineers experience on their operations to show them really what the potential is, or where the career paths are. So I think getting vacation employment experience to first and second year engineers is critical to attracting those young people into the industry. So we can show them what the possibilities are. We'll show them how they can, what impact they can have on the industry.
Okay, yeah, because the centre is working internationally, but the day-to-day lectures and students coming into the university are working more nationally. So I guess you've got a dual kind of function, and I think you're right. The industry needs to be re-educated on how they can get the people to run the plants that they want to run to keep them in business. So, no, that's very interesting point.
There is a follow-on now which I'm embarking on. The sustainability of our program now. What's happening recently is that those supporters from industry, who I said supported half the cost of our academics, those supporters gone away now. Minerals Council has now withdrawn its funding. So we've lost funding for that academic position. Glencore has stopped funding the chair in metallurgical engineering. BMA has also stopped that funding. So we're now back in a situation which we were back in 2004. So it's another of those cycles. And now we are looking to how we can support ourselves. How we can support these metallurgical programs. One of the things I'm working on now is internationalizing the undergraduate program. So there is a great demand for education in China. So there's incredible investment in education. So I'm setting up agreements between Chinese universities and Indonesian universities and other places to take their engineers after first or second year and have them transfer to University of Queensland to complete their specialist education in metallurgical engineering. So we're looking to internationalize the undergraduate teaching as well as the research now. And I think that's the only way forward I can see at the present time. And it fits into, I guess, the needs of the community and those societies who are developing their technologies in extractive metallurgy.
I could just see the CEO of a major company coming to Queensland and saying, "What are you doing? Where are my, Australian graduates. Well, he didn't support it. So you've got it's a dual challenge.
That's right. Yeah. I'd like to see more Australian undergraduates in our programs,
but they're not there, are they?
But I would like to see Australian industry saying, "Well, we need you guys," and not just when we need them, but all the time. We're building processing plants which are lasting for decades. We need an education plan which has the foresight to see what the education needs are for those decades, to keep those plants running and to keep improving the technologies and efficiencies of those plants.
I think, Peter, we're near the end of the discussion on the career, attracting people, milestones in the industry and the impact. We might just talk a little about the role of AIME and perhaps the different sister societies, TMS, SME, and so on. How has been your involvement with TMS and AIME and SME and so on?
Yeah. So I've been a member of TMS since 1980, and also the AIME, and that corresponded to the time in which I essentially changed from focus on ceramic materials to extractive metallurgy, and so that was a way which I could become familiar with the industry, to make contacts within the industry, and learn about, what the priorities were within the industry. So that networking is very important, a way of getting me in contact with people across different branches of the industry. So otherwise you're stuck in a silo in a particular university in a part of the world which is a long way from everywhere else. And so having this connection with professional metallurgists from different parts of the country and different parts of the world is been important. And that gives me an opportunity through international conferences such as the Extraction 18 program that we have here, bringing people together and sharing experiences and trying to work out a way forward and to establish collaborations with industry, but particularly for our program over the last, that's one of the focuses of metallurgical engineering at the University of Queensland, which has been going now for more than 60 years, and University of Queensland has a strong focus with industry and collaboration. So keeping those connections and having opportunities to meet with people is very important.
That's excellent. Well, look, I think we've covered the areas we wanted to talk about, Peter. Is there anything else you'd like to bring up or mention before we close the interview?
Yes, I think an important part of the message we have to get over to our potential graduates, if we're going to attract people in, is to promote the vision of the new era in metallurgical engineering. I think we've been through the down cycles economically, but metallurgical engineering is changing dramatically. The technology is changing dramatically. The focus on a broader range of elements that people hardly heard of a couple of decades ago, are becoming critical to supporting our technological society. The number of elements we use in computing systems, in our communications, iPhones, in new energy generation, this is new metallurgy. It's a next generation of metallurgy, and I think that's the thing that we should be promoting to attract the new generation of metallurgists and expand and build on the technologies and tools that we've been developing in traditional branches of metallurgy. So I see that the last 50 years has been developing a platform for development to this next stage. Because we all need metals. We all continue to need metals, and we're going to continue to need metallurgists into the future.
No, I think that's very, very interesting, Peter. They're good comments, and let's hope you can continue that role.